In this video, we are taking a look at the 1.3 practice work focusing on Venn diagrams and the principle of inclusion and exclusion, and we're going to take a look at number 3. Let's start by reading number 3 and then dive right in. Number 3 says, in a university entrance exam, 80% of students pass the English component, 85% of students pass the mathematics component, and 75% of students passed both. A, what percentage of students passed at least one of the components? So we're finding A union B there. All the elements that are in one set or the other or both. And question B, if 45 students failed in both the subjects, how many students wrote the test? We are also told not to use a Venn diagram. I may sketch one to illustrate and explain for you, but we do not need it to solve this. First thing I'm going to do right away is to find my sets. So I'm going to let E represent the set of students that passed the English component and then I'm going to cheat a little bit for the sake of time. Let M represent all the students that passed the math component, and let S represent the set of students that took the test. All right, next we're going to use our principle of inclusion and exclusion. So we kind of know which formula to use already, so let's write that out. The cardinality, or the number of students in the set of English union E union M, is equal to cardinality of E plus the cardinality of M minus the cardinality of E intersection M. So we add up all the students that passed the English component, all the students that passed the mathematics component, and we've double added those in the overlap, so we subtract it once. We know a bunch of these numbers, so let's plug them in. And we don't have an actual number, we're using a percentage, but the rules apply, it's just fine. So 80% passed the English component, and 85 passed the mathematics component, and 75 passed both. So let's find the cardinality of E union M. Let's find the number of students that passed one or both. 80% plus 85% minus 75% gives us 90%. Cardinality E union M is 90%. And so that answers A. Therefore, 90% of students passed at least one component. And I'm going to throw a quick Venn diagram in here just to illustrate this, although the question said not to. I'm going to cheat once again and use this empty space here. Technically, that's part of our let statements, but I only have so much room on my board here. So we draw our sandbox, we draw our S, set E, set M. And I know that this is my entire universe. 100% of the entries fit in here. In our shaded area here that we just worked on, there are 90% of our students, which means that the remaining, the people that didn't pass, is 10%. So we've actually kind of almost answered B just by doing this part already. So let's take a look at B. B says if 45 students failed in both the subjects, how many students wrote the test? So I'm going to let X represent actually I don't need to, I already have S. That's fine, we don't need to do that. So S is all the students in here, and we know that this value here is 10% and this value here is 45. So the cardinality of S is equal to 10%. Sorry, let me write this out a different way. Basically, we know that 10% 10% of S didn't pass. 10% of S is 45. So we're going to have 10% times the cardinality of S equals 45. And we can easily rearrange and solve. This is just a single variable right here. We could even think of it like an X. I just didn't want to introduce a new variable. So I want to get this by itself. I'm going to divide both sides by 0.1, and 45 divided by 0.1 is the same as multiplying by 10. So when we rearrange and solve, we find that the cardinality of S is 450. And therefore, we know that 450 students took the test. And that is all that we were asked to find. We've successfully found it. We didn't need our Venn diagram, although it was helpful for illustrating a little bit. And if you check the answer key, that matches as well, so we can feel confident in our answers.